Welcome. Module 12, Performance and Recovery, deals more with the network performance, monitor the network to make sure that you have after performance, and also uh, different methods to recover your network in case of something happens, which includes backups and quality of service and all the things like that. So we'll see how you can collect data from your network. Once you collect that data, can be analyzed and used to optimize your network, identify weak points on the network, and also identify places where it can fail and how to recover from those failures. So network management, it's a way to assess your network, monitor it, and maintain it. So network management includes not only controlling your network, you know, the access to who uses your network. You check for hardware faults, so it's a way to monitor your network. You ensure the quality of service or QoS for critical applications. So that's why you prioritize who gets a better uh, portion of the traffic and who gets a preference over the traffic. Also, since we gather data from the network, then you can maintain these records to do assessments and to do software configurations. And with this, you can determine, you know, the time of day for upgrading your router, your applications, which is your basically your downtime, which is the time that has less usage on the network and is more convenient to do that. Most of the time is could be in the middle of the night. Sometimes it's not. It depends on the time zone, with the countries that you work with, and other factors you have to take into account. So here, what you want is to you know, enhance the network, make increase the performance, prevent any downtime, because downtime is losses. Imagine if the college loses the network, then what happens to registration? What happens to students that want to attend the classes or any other access they need to the college? So downtime is costly for any type of enterprise. And if you monitor the network, then you can predict problems before they occur. If you see a trend or something is happening, then you can predict and be ready when something happens. So one of these monitors is environmental. Environmental is very important. You got to check the temperature on your device or your rack or the room temperature and see if pressure, humidity. There's a lot of things that you can measure there. If you have raised floor, you also have to have some flooding sensors. Or if you have an area that is prone to flooding, then you want to make sure that equipment is safe. Smoke and fire, of course, airflow, just make sure that there's the proper cooling in the area, vibration, uh, motion can be sensed by security cameras, so but this part of the environment, and even to control your lights on and off to save power or to turn the lights on when there's any movement, to record what's happening on your network. You can also have open and close sensors for the racks and the doors. Make sure that who, if it gets open, and who is there, and your power. Make sure that your UPS voltage, we'll get into UPSs later, the uninterruptible power supplies. Those are the battery backup systems. Your battery level, your outages, power consumption. Sometimes you don't want to overload a circuit. And also if you have dual circuits, so you want to make sure that if one fails, the other one should be able to handle a single side power to your equipment. So in addition to the sensors that you want to have in your network, you know, for fire, power, lighting, access doors, humidity, temperature sensors, depth, anything like that, you need to have a dashboard where you can, it's a constant monitoring. So if you have a NOC, a network operation center, then someone will be monitoring and looking at you know, these alerts. Um, Also, you can have alarms or any type of notifications. Nowadays, of course, email is very fast. Text messages is also very convenient, very fast. It goes to your phone. You can get it at any time, or you can also generate phone calls and leave messages, or you know, just notify you something is happening on the network. So all of these combined is everything that you need for environmental monitoring. So most of the applications that you use, there are many out there. There are some paid applications. There are also some free applications. This one is Peasler. Peasler is a paid application. And it will have a dashboard, so at least it will have some flashy letters or graphs and things like that that you can actually see and monitor. And like on the right, you see the level of a failure or alert. Say it can go from green to yellow and then to red, kind of like a you know a traffic light uh, design that it will notify you or a knock that even though they don't know exactly what's happening, but at least they see some red lights, some things are alerting, so they can notify the proper person to react to those alerts. So those same applications that run the environmental can also run your traffic monitoring. So the network monitor tool, it will do that for you. You can do some of this monitoring with a protocol analyzer, like even Wireshark. Many times you can just leave a Wireshark running and capturing data or just capturing certain things on your data. You don't have to fill up your hard drive with everything, but you can set up some filters that says when you see this particular type of traffic or this particular fault, then record it on the hard drive. You have wireless monitoring. There's also running software in a computer that is wirelessly set up in a place and it starts collecting data. You can have port mirroring. Port mirroring is a way to do like what's called a spam port on your switch or your router. That it duplicates everything, it mirrors everything that is sent to a specific port. So if this is your main port, let's say going out to the internet, then you can mirror that port, and then on that mirror port, then you put a collector that it will collect all that data. If you don't want to do that, you can do inline monitoring. That is a device that is called a TAP, a text access point, that it will sit in the middle, and everything that goes through it gets inspected by this TAP. It is faster because it just getting the traffic right there. Sometimes port mirroring cannot keep up with all the traffic, but the problem with the tap is that if something happens with the tap and it doesn't feel closed, so it allows traffic to go through, then your tap would actually can create a network disruption. And then all this, of course, will create some reporting. You have to create some kind of dashboard or some kind of like logs where you can see everything that's being collected, and then you can dissect all that information to find any errors on your network. So these applications can sit like that on a tab, in like monitoring or a mirror port, and the purpose of that is just to capture all the data, and not only capture the data, but by capturing the data, you can gather information on your network, on your devices, everything that is connected to the network, everything that is actually talking on your network, everything that's producing any traffic. So with that information, you can create an inventory or a map of your network, because now this application is aware of every router, every switch that's transmitting data, every workstation that you see, any client that is connected, any server that is receiving HTTP, HTTPS by port and all that. So now you can create a really nice report or a dashboard that it shows all the workstations, like I said, kind of like an inventory kind of thing. Or it's like a tracking utility that you can track users. So you can actually track a user when it logs in from one computer and goes to another computer and goes to another computer. You see how this user is being seen in different places at different times during the day, or professors here roam from one campus to another. So you can see that today he was at the Kendall campus. Then Tuesday, Wednesday, he's at the Wilson campus, and you see that person logging in different places, and all that it's stored on these monitoring systems. Now, when you did your assignment on Wireshark, you didn't have to do this, but Wireshark will set up your network card, your network interface card, to run what's called a promiscuous mode. Promiscuous mode is to allow all traffic to get through and to capture everything that goes through. Remember that when you sit on a port, your receive traffic is only destined to you, and there are other broadcasts or other traffic that gets copied over to the port that your NIC card will ignore it because it's not directly sent to your computer. But if it's a broadcast or some kind of virus that's trying to get into the ports, then by setting it to promiscuous mode, then it will capture everything. It will see everything that's arriving into the port. So yes, that's one of the settings that you need to do. But these applications will continuously monitor the network. Is always checking that. Could be a segment, could be a building, could be anywhere. Any data that goes through, it reframes everything that gets there. It gets collected. And when you collect this data, you can actually reproduce that. because you can actually on like even on Wireshark you can actually see how the data went through. So you kind of in a way you kind of like play it back to see what was happening, what went through, what failed, what got accepted, and then you can get a picture of what was happening on the network at that moment. So like I said, part of this monitoring is to find flaws, to find things that are failing on your network, the things that are not actually working correctly. So some of the things that it will do is to find runs. Runs are actually smaller packets, packets that are very small in size. So sometimes that could be part of some kind of attack or something that's happening on your network, like a ping flood. A ping flood is small packets of little pings that go through. So they can be considered as runs, which is small packets. You can have giant packets. Giant packets are just over large, oversized packets is more than the MTU. Remember the maximum transmission unit. You should usually set to 1500, but if it goes beyond that and it has to go through your network, jumbo frames it can be considered giant packet. So all that gets a all that information. Then jabbers are devices that get traffic, but it doesn't get it correctly. It's like the signal is not right. So that's called a jabber. Something that is getting distorted, that, the device is kind of retransmitting traffic or something like that. That was called a jabber. Ghosts are ghost packets usually when you're set up in a network that traffic it actually is looping around. You can see the traffic again. So those are like ghost frames. So you see that they for some reason they come back into your network and they get me seen again. It could be variations on the wiring or something like that. So you see it as a ghost. Very common is packet losses. You might see some packet losses. This is a known protocol, something that drops the packet, something that is not accepted for some reason. A network card that's having issues can get some packet losses, errors in the transmission that the packets never get there. Then it will create packet losses. Undiscarded packets, on the other hand, is packets that are completely ignored because they don't know where to, the network doesn't know where to deliver. The switch itself, it says, I don't have a client, but for some reason, this traffic is sent to this switch, and this switch doesn't know where to deliver it to. So we just discard the packet, something that ignores it and like that. And then interface resets is very important. Interface resets is just sometimes the network card for some reason will go down and come back up and go down and come back up. Case in point, if you have a duplicate IP address, sometimes the interface will drop down and come back up. So with these monitoring tools, it would show you which interfaces or which areas or which switches are having a lot of interface resets. So that's an indication that something's happening on that specific connection for that specific client that it needs to be looked at. All this will generate alerts. Can be transmitted by email, text messages, like I said, SMS, or even some of them would tie to ticketing system. So when something fails, there's a failure that needs to get reported. It might just automatically create a ticket for someone to work on it when they receive that alert, and when they get notified that something's going on. So some systems actually generates and gets these alerts or messages. Windows has all the Windows machine, mostly all of them. The workstation will have the Windows event viewer enabled, and that will log everything that happens on your computer. Any workstation will have it, so it's a good way to troubleshoot problems on a workstation. But particularly servers also is a good way to do that. Network equipment, servers, and other things, especially like Linux machine, they generate what's called syslog. Syslog is a system logging system that it will generate messages of every events and things that happen, transmission and any message handling. Sometimes it's reporting just that something is happening or something that is handling at the moment that is doing. So we'll report that on syslog. It says, oh, I guess I receive a login from this person and the login went fine. So we'll just syslog that. It will put that in a syslog. So when it comes to syslog, there's two devices you need. The generator, the device itself that's being monitored is the one that generates those syslogs. Is more like a UDP, a one-way communication. It will just send out syslogs to a syslog server or collector, and the collector is the one that gathers all this information. So normally you want to have a syslog server that works as a collector with a pretty much, a good amount of hard drive so you can collect the information. Um, we In my area we run a syslog server, and it happens that I was sending all the logs from the firewalls and the DHCP servers, and the information was so much that it would actually bring down the application. It's a small software, it's not a large application, but it I think it was able to handle like no more than 3 million events within an hour, and the firewalls, DHCP and all that, and DNS were actually generating more than 3 million messages within an hour, and it would just freeze the software. So we had to stop them, send them somewhere else. But yeah, those devices are constantly generating syslogs, and they go to the collector. Now, I wish we could spend a whole chapter on just SNMP, because for network monitoring, it's one of the most important. Simple network management protocol. It's a protocol that is made just for that, for monitoring. So you can send information to a NMS, a network management system, that collects all the data. It will manage the devices, because SNMP works two ways. It can generate messages, but you can also make changes on the devices through SNMP. Back in the day when we had the Nortel equipment, Nortel switches and Nortel routers, they had a software that it was all completely SNMP based, and you can actually configure the device from scratch just using SNMP, because you not only collect information, but you can also send information to it. The way that this works is through a MIP, the management information base. The management information base, it's like a tree structure, right? That it starts from a single point, and it starts expanding like in little branches and branches. It's a hierarchical structure, so it has some like basic management systems, and then more proprietary systems, entries. So it's like a large database. In a way, it's this large database that the device starts storing information on those fields, and you can actually go and collect those fields. For example, you can go into a network interface card and collect packets in, packets out, errors in, errors out, if the interface is up or down, if the interface is enabled or disabled, if it connected at 100 meg, a 1 gig, a 10 gig, what is the speed that is connected on, any errors, any resets, and then through SNMP you can manage it. So one of the fields is to enable the interface through SNMP. You can actually disable that interface or change it to says, okay, you're not going to be auto configured for the speed 10 or 100, 1000. I'm just going to hard set it that you'll be only 100 megs, and it only save the connection. It's just like if you configure it through manually, you can do that through SNMP. So SNMP is very a critical part of networking management, because it's not only for monitoring, but also to manage it and make changes on the network devices. Windows machines, you can also enable SNMP on Windows machines, and you can also collect information from that. SNMP has also two ways that you can generate a message called traps, that the trap will go send out by itself, or you can actually go in and fetch the information out of the device. So each device has to be embedded with that agent in it. If a switch is unmanaged, it will definitely not have SNMP. Yeah, I remember the unmanaged switches don't have an IP or any way to manage the switches, so you won't get anything. But if it's a managed switch, it will have SNMP. Well, it depends. If you have one of those small home devices, most likely they don't have SNMP, so you cannot gather information. You can go and remotely, connect to it and see if an interface is up or down or something like that, but you cannot do it through SNMP. Remember, if you have an NMS, the NMS will have a copy of that management information base database, and is able to correlate those fields and to see when the data is being collected, that what the data means. But temperature of the device, power, there's so many things. I mean, SNMP is a large database that goes on every device, and every device also will have a proprietary branch on that tree that the manufacturer can create their own fields that they want to be, allows you to get that information or to change information on your devices. So SNMP has gone through a few revisions. SNMP v1 was the original version and is rarely used. SNMP v2, it increased performance and it has more security. SNMP v2 has a sort of like it's called community, and the community, it's a password that you have one for read and one for write. So if you have only read access, then you can have only the read community string. But if you need to write on it, then you have the other community string, which is like another password. SNMP v3 takes it into a higher level with a different type of authentication and validation and encryption. So now all your messages are not sent out in the clear because SNMP is on the clear. So SNMP v3 it will encrypt your data and you can select what kind of encryption you want to use. The MIP is still the same because the values are still on the same location. So whatever values you read from SNMP v2, you can read it from SNMP v3. It's just that SNMP v3 is more secure because of the authentication. Now you need a username and a password and what kind of encryption you want to be using. For also you have the read and the write. So it provides better security and is definitely more efficient. So this is what I mentioned before. There's two ways to communicate with a MIP agent. You can actually fetch information. You get send an SNMP GET request, and then you get back an SNMP GET response where you query information out of the device. So this is a TCP communication. But you also have the UDP communication, which is the device reporting itself about some communication or some alerts or something. Case in point, we monitor a lot on the UPSs when the UPS goes on battery, or when you lose your input power. So when you lose your input power, your device will go into battery mode. So those UPSs, the battery backups, can send an alert and say, hey, I lost input power. Hey, I'm on battery. And it might even, some of the UPSs that we have, they're from APC, American Power Conversion, and they will report, I'm on battery and I have 35 minutes left with this current load. And then every 5 minutes they'll come back and say, hey, I'm still on battery and I have 20 minutes left on battery. And those are completely unsolicited traps. They're generated by the device. Of course, you have to configure the device to configure where to send those. You have to configure them with the NMS server or the collector, whoever is collecting that data, to receive that. And it has to be set up as a SNME trap receiver in order to collect those. It uses UDP or TCP 161 and 162 for the two types of communication. So those are ports that you need to have open on your NMS server. Remember, NMS is the network management system. Now, NetFlow, it's a proprietary protocol from Cisco. NetFlow would actually send every possible information you can get about a transmission from a client. You'll see where they're doing, where they're going to, what kind of data they're getting, if the data was there delivered correctly, was the data sent out correctly, and all of this has to go to a NetFlow analyzer. Now, this NetFlow analyzer, they're very busy devices. These devices are collecting massive amount of data from NetFlows, so the switches need to have the capability to do NetFlows, and then the NetFlow analyzer also has to have the capability to be collecting the amount of data at the speed that is being sent to this. Imagine if at the college we have like about 17,000 ports on all the switches, so you might need multiple NetFlow analyzers in order to collect the data. Some of these are hardware based, some of them software based. Of course, the more independent you can have it with its own storage is better. It's the only way that you can track any traffic that's happening on your network. It sees everything. The NetFlow analyzer can start looking at the behavior on your network to see what is normal and what is not normal. So remember that computers are intelligent machines, right? You tell it what to do, and programmers will create a software that would analyze this, and then you teach the computer a way to analyze the software. So any NMS will set up like a baseline. So we'll do a baseline set. Okay, this person comes in at this time in the morning. It generates some traffic when it starts reading emails, and then it goes to work, and traffic kind of slows down. And then it comes to lunchtime, and he goes into Facebook and Twitter and all this Instagram through the web, and you start like downloading pictures, and it's more intensive. So you see that baseline that at lunchtime it goes up, and then it goes down again when it goes back to work. And so you start seeing all that trend, all that traffic. So you can analyze all that data like that. So you can see not only that on a workstation, you can see it on a backbone, utilization rate on each interface, how many times a user logs in and out during the day. I mean, if a person goes out to lunch and logs out and logs back in, it can keep all that trend and it create a baseline and said, okay, this person logs in and out once or twice a day, maybe 3 or 4 times, maybe 5 if something happens. But when you start seeing a lot of long in and out of this person, like 15, 20, 30 times during the day, then it will impact it will see as a performance problem. Something is happening, and it will send an alert. You can see the number of protocols that you're running, and all those run Javas and giant, all those error statistics can be collected from the network and create that baseline. The frequency on application use and the bandwidth usage. That also, last week I saw a spike on the internet usage. For some reason, it went up to outbound to like a 1 gig solid for like about 4 hours. It was from like 10 in the morning to 2 in the afternoon. It was a solid bandwidth, like a 1 gig. And usually we don't serve out to the internet that much data. It's usually in the hundreds of megs, not on the 1 gig, and not like solid like that. It turns out that some student had a lot of videos with raw data, and he was uploading that to Google Drive, and it was like in the neighborhood of like 2 terabytes of videos. So it took like about 3 or 4 hours to upload all the 2 terabytes to Google Drive. And that's why I saw that, because that computer had a 1 gig interface, and the maximum that it can do is probably 700, 800, and the rest was the rest of the college doing traffic. But the NMS that we have, we saw the baseline, the normal traffic that we see normally, and then when I saw the graph that changed and it went to a solid 1 gig, it's like, this is not normal. So then we investigated and we saw what it was. I mean, it was harmless, but just in case system got compromised and data is being sucked out of that system, then we would have caught it by the same behavior that we noticed with this computer. So baselining, we're doing a baseline. It's important because it measures the trend on your network. What is happening right now? What is happening every semester? Is the traffic increasing so much? So we see at the college an increase of internet usage as the time passes. As we get more students, the college gets bigger. There's more applications. There's more labs. During the pandemic, for example, we saw a drop on wireless. There were no students, no people on campus, but of course the VPN, we saw the increase that normally was 100 to 150, maybe 200 users connecting during the day, connections to the college in one day, and all of a sudden it went to like 1,500, 1,800, and then we started to measure that. It's like, oh my God, so how many VPNs can we handle? And we're starting to see if it was going to go to like the 2,000 and 3,000. It's like, what's going to happen here? But no, it's still like within the 1,500 range. So it's 1,500 people connected VPN to the college. So you can see all your critical network, the functions, and provides that data so you can see what's going on your network. Some software applications, they're freeware. They can create this baselining. I can show you in class. There's one called Cacti that it does graphing of the interfaces. It's a kind of manual work to do it, but once you have it set up, it collects the data and it helps you a lot to see what's going on your network. You can also have the key performance indicators. That is just to see the interface statistic, utilization, error rate, packet drops, any of that performance. So you can set up your baseline to see, what's acceptable and what is not acceptable. So if you have a utilization, like I said, outbound, that it was always less than 400 megs and all of a sudden went to over 1 gig, then I see that. Error rate, if I see that there's a lot of errors on the interface, it's like, well, what's happening here? It's this Windows or Intel push a new driver for the Intel network cards, and is creating problems, communication, and you get a lot of error rates, then we have to see where is that coming from. I know you start to investigate when you see things that are changing. You can also do bandwidth management. Bandwidth management is just a way to look at your data, how much bandwidth you have, how is the traffic being utilized, what is taking up your bandwidth, and then make changes accordingly. You can there are some devices that you can have with the network to even through your firewalls to limit the amount of data that can be transmitted to a specific host. Let's say um, I don't know, Netflix. If I want to limit how much Netflix people can ingest from the outside into the college, then we can see that if there's like too much coming in. So you can play with the flow control. Just look at the interface and the protocols and see what's going on there. You can do look at the congestion control. Just to adjust the way the network responds to this performance and make see where the changes are and why it's happening and make sure that it doesn't get any worse than it is. And also QoS is quality of service. Quality of service is a way to prioritize your network. Remember that even internally within your network, voice data is really important. Video is important. So you want to make sure that voice and video has a higher quality of service. Remember that on the header, your Ethernet header, there's a DSCP value. The DSCP value tells the network how important is that traffic. The higher the DSCP value or the specific DSCP value, it will tell you if that's voice or data or normal traffic or any type of traffic. So by prioritizing that, I said, okay, when you see this DSCP value, then give it priority because that is voice. I think the DSCP-46 is voice, if I'm not mistaken. A DSCP of 0 means I'm normal traffic. I don't need any special treatment, so just send me out whenever you can, and I'll just go along with the rest of the traffic. But if QoS comes in there, that is voice, and voice says, hey, I am a priority, and I need to go first. And then those traffic make sure that it doesn't get get it slowed down or put on the side or get delayed during peak times on your network. Peak time, of course, is when you get the heaviest amount of traffic on your network. So the flow control is a mechanism that you use between a client and a receiver, a sender and a receiver. That way you control the communication with the two and between the two, and they have to agree on the amount of data or how often you can send data to me. So it's just to make sure that one equipment doesn't overwhelm the other side by sending too much data too fast. So you can have the stop and wait method. The stop and wait is you send information, and then you stop and you wait for the acknowledgement that you received that data, and then send another one and back and forth. You can have the also the go back and sliding window method that it will send you information, and if it doesn't receive it, then it will send everything again. It could be multiple packets at the same time, or a specific multiple packets together, and then if I don't get an acknowledgement, that means that something went wrong, so I'm going to send it again. But I send the whole thing. Now, the selective repeat sliding window, it's where you selectively said, okay, I sent you like 4 packets, and I receive the acknowledgement on 2 of them, but 1 of them didn't, so I'm just going to send that one back. So out of that, a collection of packages that I send all that information, then 1 of them out of the 4 did not get there, so I'm going to just select that one and send just one retransmit for that one single one. So here's the best way to see it through the graph. The go back in sliding window is if I'm sending packages in sets of 3, so I send 1, 2, 3, and I receive acknowledgement, and then say 4, 5, 6, but I get a timeout. So since I got a timeout and I'm sending 3 at a time, then I'm going to send back all those 3, even though you may have received the other ones or not. But I'm going to send all 3 at the same time. Now, if I want to be selective, then I'll repeat only the one that I didn't send, the one that I did not receive. Then I can retransmit that one to make sure that you get that specific a packet. So on the next time that I send the packets, I'll send you the one that you're missing. So that's what's called selective. I don't send everything I get. Now, granted, all of this is done automatically on the software on the computer. This is so that you know how flow control works. So when you're doing troubleshooting or you're doing packet analyzing, then you get to identify these problems. This is not something that you're going to adjust on your computer and say, oh, let me use just the stop and wait method, or I'm going to do, the go back end sliding window. Is like, no, this is something that is already set on the software, or something that the devices end to end can agree on what method they're going to be using. This is not something that you per se are going to configure. But when you analyze it, you want to have to be aware when you see that 3 packets are being resent at the same time. It goes, it just sent the whole thing again. Or you might see on the packet analyzer that on Wireshark that only 1 got retransmitted. Because, oh, look, I got 4, 5, 6, and then 7, 8, 5 again. That's because it retransmitted the 5 selectively. So in addition to that, you can have congestion control. Again, it's something that runs to your software, something is already embedded on the network card and all that. But these are things that you should know when you analyze or look at network errors on your enterprise. So congestion, there's 2 ways. It's the open loop congestion that gets analyzed before it happens, before a congestion happens on your network. But if it's already starting, and you're seeing it, the congestion is happening right at that moment, that is called a closed loop congestion. So open loop congestion is before it happens, but while it's happening, that you capture it right when it's happening, is a closed loop congestion. So for the open loop control, which is before it happens, you can have retransmission policy, you can have the window policy, remember the sliding window, the acknowledgement policy. So when I send a packet, I need that ACK, the ACK coming back. Discarding policy, that some frames can get discarded. If there's too much congestion, you can set a certain amount of this discard you can do. And the emission policy with the routers and switches can reject new traffic that'll continue to create a congestion. When I see that I'm sending traffic to a device and devices keeps getting behind, not processing the data correctly, and then I keep sending more, and if they're going to get discarded, so the emission policy will help the network to throw back and a message to the sender goes, wait a minute, you have somebody's getting congested here, you have to wait. But this is all the open loop congestion control. Now for the closed loop congestion control, then there's several methods that the network will use. The implicit signaling is just to detect the congestion, and it sends some messages that some misinformation was sent. The explicit signaling is when it happens on the network, but then you alter the data packets to tell the sender that something is happening, something is wrong. So it's like you need to back off a little bit because there's something happening on the network. So that's explicit signaling. The choke packet is a little bit smarter. That it's when there's a congestion, it would actually send back automatically a choke packet to the source to tell the source, hey, there's a congestion here, you need to reduce your rate. So force them to slow down the traffic because you're flooding my interface. So I'm going to send a choke packet to say to do that. And or you can do, or the device will do a back pressure that it will just like stop the communication with sender and receiver completely until the congestion goes away. So once the receiver can send more information, they will start collecting data again from the source. So that's why many times it happens on your video. When you see your image pixelized, so you're still receiving some data, but some other one is pushing back some of the video. They did not receive it. You might have said, okay, I need to get the audio. So send me the audio, but on your video, I'm going to back pressure it. I'm going to send this, just set it back a little bit so I can catch up with what's going on here. I might lose a few frames, but if it's video, it's okay. You can see, the jumping images on the screen, but your audio, which is the one that you want to receive first, it will get there, but that back pressure is put on the video side. which is traffic that is important, but it can be held back until I can catch up with what's going on, so I can get my audio and the video sync again. So quality of service is just a way to prioritize the certain data on your network. Especially voice and video. And this is interesting. Voice and video are considered delay sensitive. Of course, delay sensitive because you want to get that video, you want to get a good image and everything goes smooth, and you want to hear that voice is always there and is in sync. So they're delay sensitive. So you want to prioritize that network, that traffic. But also video and voice are considered loss tolerant. So it can tolerate some packet losses. That's when your image gets pixelized, when you get your image freezing for a few seconds and then it comes back. When you're on your phone, sometimes you hear that your voice is cracking up, that you see that, oh, I cannot hear you correctly, it's breaking up. So that breakup is because it's loss tolerance. So the network is allowing for the voice to lose a few packets and then continue the voice, and you're like, can you say that again, because I didn't hear you right, because you're breaking up. So that breaking up is because the voice, even though it's prioritized, is still a loss tolerant, because they want to be able to catch up and continue with the voice. It's not going to delay it or hold it back and then send it later, because it creates problems. You want voice and video to be more like a live streaming. You want to have some delay, but it has to be a very minimal delay, so you don't have that cross-talk communication when you're on voice. So you want to prevent those delays, the distortion on the communication. So QoS is a way to prioritize this, and we'll see different techniques that can be used on the network, and you can control this, or the devices can request it, but the network devices have to honor these settings in order to work. So one major part of QoS is traffic shaping, or packet shaping, which is a way to control the packets, the data streams, and to manage it as they go through the network, and see who goes first, who goes second, who has this bandwidth, who doesn't. A case in point, back in the few, like 10 years ago, the Tamiami airport, where we have some classrooms there, had a T1. T1 was 1.5 megs, very, very slow connection. Even for today's standards, it's very, I guess, almost unusable. So we had to use QoS to prioritize the voice, so at least the calls can get through. I was there one time. I was trying to download I was trying to open remotely a spreadsheet, and I just couldn't. Just the video across from the remote desktop, it was just not enough to do it. So I actually had to download the file and then open it locally there, because it was just not enough. But then, even though I could flood the circuit by downloading that file or trying to do the remote desktop, voice was always going through, because voice was being prioritized. But on traffic shaping, you can shape how much percentage, how much bandwidth you want to use this, so you guarantee the amount of traffic that you're going to be using. So you can delay some of the traffic. It's called buffering, so you can buffer some of that. What if you get your web page 2 seconds later, 3 seconds later? You see that it takes a little bit longer, but you're like, the network is slow, and then you get that page. Well, the network is slow because something else is taking over the traffic that you want for somebody else that's more important. So something that has less priority, or priority of 0, then it will get this buffering. But there are many ways to control this. Like I said, you can limit the throughput to an interface, or you can limit the traffic that flows through an interface. There are many ways to do it. So this is also called traffic policing. The traffic policing is a way to, like I said, to provide more a higher priority to the voice. I think that at the time we had it, that at least 20% of those 1.5 megs has to be dedicated for voice. If there's no voice at the moment, internet and everything else, web browsing, can take over the whole bandwidth. But the moment a voice connection gets established, then that voice can take up 20%, and everything else has to be wait, has to be buffered. So that's what's called traffic policing. So if we look at a graph of something that is being thrown with shaping, you can see those flat lines that rather than going all the way like beyond 100 megs, then we can say, nope, I'm going to police the traffic, and I'm not going to allow whatever this type of communication it is to go past 100 megs. So at that point, it gets flat. So that's where you get your traffic buffer or delay. But the rest of the time, when you're under 100, then it looks like normal traffic. So there are many ways to control that. It depends on what you're doing or how you want to do it. Like I said, this can be done with a packet shaper, a device that's specifically made for this, for traffic control. The routers themselves, routers are capable of doing quality of service. So you can do it by protocol, by IP address, user group. The diffserv is a flag of that IP packet. Remember the Ethernet header has that diffserv, differentiated services. That voice gets a flag like that, or VLAN tagging. The VLAN tag, which is a layer 2 a mechanism, then you can say, okay, this VLAN has more priority than some other VLAN. So you have your voice VLAN, your data VLAN, so you prioritize your voice VLAN. Cisco has a mechanism to identify or assign a VLAN that is for voice, so it will treat all that traffic differently from the data. So you have a data VLAN and a voice VLAN. Or a service or application. I mean, if you have one of these, packet shaper devices, you can do this quality of service by the application. It says, okay, I want this application to work in case Teams. Teams is kind of, it's a, conferencing and all that, but it still can be the packets. You can see that the application it's Teams. I can show you in class. We have a packet shaper that I can show you in class how the packet shaper identifies the traffic and some examples. But I can guarantee that Teams will have a specific amount of bandwidth reserved just in case it needs it. Then you can take that. So I want to make sure that all my Teams meetings go through in the college, even in a moment that everything gets congested. So diffserv, the differentiated services, it works at the layer 3. It works on all the networks, all the especially voice systems and video systems, cameras for surveillance. They will support the diffserv, and you can, like I said, they have to be configured and enabled on your switches, on your routers. If one device in the middle doesn't support this, what it will happen is that it will take that diffserv value and set it back to 0 if it doesn't support it. Even if it comes in with a specific value, it doesn't honor that, it will just set everything back to 0. So you got to be careful, make sure that if you want to prioritize voice or video, any service like that, that the diffserv capabilities are enabled on your devices, and that it depends on the device. It might have it disabled by default, or others might have it enabled by default. So yeah, but you still have to check. So the diffserv uses the DSCP value, differentiated services code point, is a 6-bit field that it gets added to the header. So you can have two types of forwarding: the EF, which is expedite forwarding, minimum departure rate. So as it comes in, send it out right away. And the should forwarding, it says it comes in, I have to make sure it doesn't get dropped, it doesn't get redirected, it has to go out. It has to be, a different level of service, but still it has to be make sure that packet gets forward. Voice will use the EF or the expedite forwarding. Now, class of service is similar to QoS, when you assign a value to see, which traffic is more important. But COS, or class of service, or COS, it actually works at a layer 2. This is more for the traffic now within the VLANs. It would assign what's called a PCP, a priority code point value, that it goes from 0 through 7. So it's actually 8 values, because 0 counts, right? 0 through 7. And based on what level that you put, that's how the traffic is prioritized. Now, again, it must be supported on your devices, and it can be used together with QoS. But the cost value is important. Cost value, usually 0 and 1 is just like the basic, like a background process or best effort, or it's a little better traffic, then you go to 2. For critical applications, you can go to 3. Normally, voice and audio, it will be placed on 4 and 5. I think cost of 4 is for video and cost of 5 for voice, and then 6 and 7 is for the high priority, but that's for like network controlled or interconnection, control on the network. That's for the highest priority. But voice, a video and voice will go on video and like 4 and 5, like around that level. But the device will actually see those headers on the frame and prioritize accordingly. Like I said, if you don't have it, then everything has priority of 0, and it's just treated as a normal traffic, best effort, whatever I can send it, it will send it. This is similar way that QoS works. Now, disasters happens on the network. I mean, of course, not a disaster, but as a hurricane that we experience here in Florida. But something, a catastrophic failure of a device. Imagine your border routers or your main firewalls or some fiber cut. It's a disaster. It stops the communication. It stops your business. It stops your traffic, and your network can't transmit the data. If there's no data transmission, there's no internet, there's no orders, there is no payments, there's nothing. So all of this is what's called an incident, and each incident should have a clear way of how to handle that. This could be a security breach, an infection, environmental issues, but every incident should be handled either through documented procedures when a specific incident happens, or treat as a new incident where you have to analyze what's going on. So a disaster, again, is something that completely brings down your network, or something that damages part of your network. We had a problem recently that DNS, the Oracle Cloud, failed. They were down for like about an hour. We have no control because it is a cloud. We have no control over that. So anything that had to do with the student records, the student registration, students scheduling, everything, all those systems are in the cloud. So once the DNS went down, it was an outage. It was a big outage. So that is called, it depends on the gravity, then it is called a disaster. So there are mechanisms to recover from a disaster. So if you don't have a written plan, then you have to write one. See what do you do when an incident happens? What is your response? How are you going to deal with this problem? Who's going to be involved? So that's why you need to do a preparation, then detection and identification, see what's happening there. Containment, how are you going to contain the problem? How are we going to resolve this and remediate that? Apply your solution, see if that works. If that doesn't work, then you go back again to detection and identification in case it was not detected correctly, containment until you get remediation. Once you remediate the problem, then of course it goes into recovery mode where you start recovering and everything starts to come up little by little. Services start to respond again. And then you review everything that happened, and most of the time you document the key players on that, or the equipment, or what was involved with that on that outage. So good planning is always good to have. I mean, you have to make sure they have business continuity, so the company will continue to work despite of any interruption or problems. We saw before when you can have redundancy, when you have 2 sets of routers, 2 routers, 2 firewalls, 2 ISPs. If you have a data center, you can have a backup or standby database for some, software. So if one fails, you have the other one to is either active. So when something is active, and the other one come in right away, or active standby, where you either automatically comes up or you kick it in. So you should have a disaster recovery plan which shows all the process of what to do if anything has to be done manually, if things is automatically, and if it's automatically, sometimes you don't know that you have an outage, but because the system works so well, it just brings up something else and it's working, and then you have to make sure you get those alerts from the logs or your NMS that equipment A failed and B is taking over all the traffic and is working correctly. So on a recovery plan, yeah, have contact names, phone numbers, or who should get involved in this. Details of the equipment, what is it do, what does it work, what does it connect to, where is this information to, the backups, where the backups are, and if you need to recover from a backup, then how you recover from the backup. So sometimes you have to do a little exercise of backup a system and then recover it, break it. Well, not break it, but you know what I mean. Pretend that it broke, and then how will you recover that piece of equipment? Can you rebuild it? And how long will it take you to rebuild it? And that can be documented. Now you can see you have a procedure that says, okay, but if we have this failure, it will take us at least half an hour to recover from that failure because of all these procedures. So you need to have detailed network topology, the redundancy, any agreement that you have with carriers, anything that if something fails, what is it going to happen? When you have this kind of disasters. And it's a strategy to do this and testing. Like I said, you have to test your system. Don't rely on those backups. Like, oh, I have a backup. Well, have you ever tested that backup? You backed up the configuration of a switch of a router. Well, do you know, or your technicians know how to take that backup and put it back on the switch and restore the configuration of that switch? Now, sometimes some backups don't back up everything. There's some passwords, especially SNMP. SNMP is one of those that even when you do a backup, it doesn't store, at least on the ones that we do, it doesn't store the SNMP passwords. So when you restore the switch, it's operational, everything is fine, but the network management cannot see it because the SNMP credentials are not there, and it fails. I got to tell them, hey, by the way, remember they have to do the SNMP manually. But if you have a procedure that says when you restore this backup, please reestablish the credentials or the passwords on this SNMP. But it's just to have a plan to manage any crisis that can happen on your network. We mentioned this before on another chapter. When you have the cold side, the warm side, and the hot side. Cold side, of course, is cold. It's equipment that you have. It might be in boxes. It might not be configured or updated or anything, but when you need it, you take it, you update it, and get it up and running. We do have at the college an spare router. It's a cold side. No, it's not a cold side. It's a cold piece of equipment because that one is there. We use it for testing and we as a lab, so it doesn't have any specific configuration on it, and it doesn't really match any of the routers on the campuses. But it's a full chassis with full CPUs that it can be recovered. You have can have a warm side with where you have equipment that is almost ready to go. That all they need is some TLC, configure some of the devices, configure some configuration. Like we have that one. The CPU has the right code, so I don't have to do any firmware upgrade or anything like that. But all I need to do is to put the right configuration for the right site, and I can just take it there and recover it. And also, then you can have the hot side. With the hot side, is completely a mirror of what you have. That whenever something happens, it's fully ready to go. You just basically flip a switch and then send the traffic to the hot side. You can have what's called a disaster recovery as a service in the cloud. That's well, I don't know if it's quite inexpensive like it says here, but because you have the equipment sitting there in the cloud configured, ready to go, and you have that space reserved. So if something happens, you can send everything to the cloud and have everything running. Those system has to be fully tested to make sure that when something happens, you can really just flip over and go to the cloud and have that equipment ready up and running. The problem with things like this, of course, any disaster recovery, is that when you have a hot site, it has to be a mirror. So any change you make on one side, you have to go and replicate on the other, or have a mechanism that replicates everything. Databases need to be replicated. Configurations to be replicated. Any piece of equipment that gets changed has to be replicated. So everything that you have on one side has to have it on the other one. And in the cloud, exactly the same thing. Well, power management, we all are aware here in South Florida that we have power fluctuations all the time. When we lose power, then of course you want to make sure that you have some way to get your power restored. Sometimes the equipment will get damaged. I mean, 10 years ago, 7 years ago, I got a lightning hit in my house, and surprisingly, it didn't uh, damage most of the electrical equipment, but somehow it got into my network switch and it fried every network card on every device that I had, including access points, computers, TVs, anything that had a hard wire. Of course, the wireless doesn't get affected because it's wireless, but the access point itself had the network card completely blown because of the electrical pulse that it sent when the lightning hit me, or hit my house. So you can have a surge, which is increase in power, right? That can do by lightning strikes, electrical problems. If you're close to somewhere where there's like a big motor, it can create a surge. Noise is fluctuation of the voltage caused by sometimes electromagnetic interference, the EMI, or microwaves, anything that it has magnetic, anything that has a motor. Air conditioner blowers would actually introduce noise into your power, and it can affect your computers. Remember, the computers are using sometimes the electrical power as a clock. In the United States, we have a 60 hertz electricity. It sends the 60 hertz on the electrical power, and computers uses that also to set up internal clocks and things inside. So if that gets noises and it doesn't get the exact 60 hertz, it might create some problems with the computer. It's not going to burn it, but it will create some, unexpected behavior on the computer. You can also have a burnout, which is a decrease in voltage. It's sometimes called a sag. So it's the opposite of the surge. So you got a surge or a burnout. And a blackout is a completely power loss, right? You heard that on the news. Cities that they got a blackout, it completely loses power, and that's where you need to prevent those things. So to prevent any of these power outages, you have the UPS, uninterruptible power supply. That's a battery backup system that in case of electricity goes out, a battery will kick in and it will keep producing power as long as the batteries are fully charged and as long as the batteries are in good condition. And it depends on the load, the batteries will provide any energy for that. You can have a PDU, a power distribution unit, more like a power strip. Right, so it's a managed, a glorified power strip, but it's a PDU that it sits on, you sit it on the outside the rack, usually one on the left, one on the right, so you can have dual power, and that's where all the equipment connects to that single power source. UPSs can be two types. You can have a standby UPS. That the standby UPS is normally the ones that you buy from home or standby. The battery is there on the side, fully charged and all that. The moment that you lose power, it switches to battery. But it has to do a switch. And when the power comes back on, it switches back from battery source to the input, the power company. Sorry. Then you have an online UPS, which is fully in line. It takes the AC power, it goes through the batteries, and from the batteries, you provide power to your load. So it's actually it's providing power directly from the batteries constantly, but the batteries are charging the power is charging the batteries, and the batteries provide power to the load. So that's an online UPS. The nice thing about those is that the moment you lose your input power, you continue to provide power from the batteries. So there's no switching. You continue to provide from the batteries because you normally receive power from the batteries. So of course, the online UPSs are for larger systems, a much larger system. Even in your closets, if you're on your IDFs, intermediate distribution frames, remember the small closets on every floor or other buildings, now your MDF, you will have the standby UPSs, and then on your MDF, your main distribution frame, you'll have the online UPS to provide power to your whole DMARC equipment and your edge equipment and servers and anything that requires the online power. All right, so the auto likes a cute picture. So this one, you have an outlet from the wall that it fits the UPS, and the UPS has the outlets in the back that it goes to a PDU, and the PDU provides power to all your devices. In this case, this is a standby UPS. It has batteries. It depends on the capacity of the UPS will have multiple batteries. Normally they come with like 4, but some of us will have like 8 or 6 or 8 batteries. It depends on the size of the UPS. But when you lose the your input power, it switches to battery and it keeps providing power to the to the load. So this is a little description on a standby UPS. On the left, you see that the batteries are being charged, right, on the normal, but you receive power straight from your outlet to your load. Um, in the moment you lose your input power, you get a power loss, then now you switch to the battery, but that's like it's an automatic switch, so it's within milliseconds, so your equipment doesn't really shut down or reset or anything like that. So you go into battery power. On the right, you'll see an online UPS. So uh, the power company will provide you power to the batteries, keep the batteries charged, and then your load comes from the batteries. The moment that you lose your power, you have your power loss in the middle. Um, the batteries keep providing power to the load, even though it doesn't have that input to keep charging the battery. So that's when you start like losing, charge on the batteries. On the UPS, well, not an abnormality. Sometimes if you want to bypass your UPS, so you go straight from the power company power for maintenance, battery replacement, or anything like that. Then you can flip the switch into maintenance mode, which will go straight. The problem with that, any lightning at that moment, you have no UPS. But you do it at a time that in the morning or so on a weekend or something like that where you don't expect the power to flicker. But if it does, then there's nobody in your area. Those batteries need to get replaced. Normally on the smaller UPSs, the lifetime is 4 years. It depends also on how many times they go on battery and the temperature of the room. The hotter the temperature, the less lifetime the batteries will have. On the normal conditions, like I said, 3 to 4 years is normal, but you have to set up a schedule to replace those batteries. On a larger online UPS, or you also have to keep on testing the UPS to make sure that the UPS is in good condition and that the batteries are at optimum. That will have larger batteries and more batteries. It's more like a string of batteries that it requires more specialized a company to come in and maintain those large UPS. You gotta be careful because those batteries, they are usually 24 volt batteries or 48 volt batteries with a large current, and that current is what kills you. So the smaller UPSs, they got like 12 volt battery. Those are it's like a car battery. You touch the leads and nothing happens. You're not gonna feel anything. But they're 12 volts and they have high current, but not really high current. On the online UPSs, those are larger batteries, 48 volts, but it's a higher current. So you have to make sure you don't touch those unless you're qualified to touch them. So UPSs need to be sized to your needs. So they have to see how much power you're going to need and for how long you're going to need it. Sometimes you need light conditioning. Light conditioning is a little bit more expensive, and also the cost to maintain this and the cost of the UPS. If for an office or home use, do not plug in a laser printer on a UPS. The laser printers have a heating element that draws a lot of power, and you don't want to put that strain on the UPS. But besides, if the power goes off, you don't want to power a printer. What's the point? You want your computer and you want your monitor. Also, as I mentioned to friends, if they have a UPS and the power goes off, that amount of power that they give you is for you to close your files and shut down the computer. Is not to say, oh, how much power do I have? 20 minutes. Oh, let me finish this file. No, not let me finish anything. Close your files and shut down the computer. If it's a server, by all means, shut all the services down and turn off your server. Don't try to keep on finishing something because your server is going to shut down, and especially Windows, some files can get damaged. If you have a database, files will get damaged, so you need to shut down and all that. You can have also a generator, right, as a backup source. So in case that something happens, your generator kicks in and it takes over. So many times on those large UPSs for like a data center, all you want is the UPS to hold for a few minutes. 5 minutes tops. All you want is time for that generator to kick in automatically, rev up the speed, get power and start putting power into your system. So now your input power is restored, right? And most likely this will have a automatic switch that when the FPL, your input power goes off, it will go into generator, and then you start receiving the generator. So, but the switch should be quick. Generators, yeah, they run in diesel, propane gas, natural gas, steam. I don't know if we have any steam here, but I guess in some places in the country will have it. Here in Florida, the best thing we can do is natural gas. Since we're not prone to earthquakes or anything like that, we know that we'll have the underground natural gas for a long time, even though we have a hurricane. So natural gas will provide a perfect fuel for generators in Florida or South Florida. I don't know the rest of the state, but at least here we have that. Propane gas is good too because it will last longer, but for liquid propane, you have to get a service to reload your fuel. The same thing with diesel, right? But natural gas is a good choice. I know that a lot of the supermarkets are now required to have a backup generator, and I know that 99% sure that they run in natural gas because as long as the gas company keeps providing gas, you'll have those generators running. So now when you have that combined with UPS, now you make sure that you're always going to have power available, right? If you have a generator in your organization, it has to be tested regularly. And also the fuel levels, it's an engine, so it has to be maintained. The generator itself can decay with time, humidity and heat and stuff like that. So it has to be tested, it has to be maintained to make sure that the generator is up to performance of what is needed. It's usually before hurricane season, get that generator tested to make sure that it starts, that it works. At Miami-Dade, I think we run a generator test once a month. So once a month, they turn on the generator, they let the engine warm up. Once it gets warm, they shut it off. They make sure that the UPS actually can run from the generator. And lastly, on this chapter or this module, backup systems. Remember, your backup system is for archiving or safekeeping. Archiving, if you want to keep old data, you don't want to keep that on your system and just put it away. Or for safekeeping, in case that's something you need to look at it again. You have to keep a few things in mind, decide what to back up. You don't want to back up everything. It's like if I have a Windows machine, do I need to back up the operating system? Well, no. I might just need to back up the data. If anything, for my disaster recovery, I should have instructions to say, hey, reinstall Windows, restore this application, and restore the data. And that should work. Select your backup method. You can have cloud backups, like this person that was backing up your files on a Google Drive, but it was taking up all my bandwidth. But now consider also that if you back up on the cloud and something happens, you want to be able to download from the cloud. So if the data is not next to you, close to you, and it's in the cloud, and there's problems with the internet getting out of the area, then you're going to have issues. So think about the cloud thing. As you heard before, I'm not too fond of the cloud yet. I say it'll take me a few more years to get more used to trust the system. Also decide what type of backups will be made regularly. There's some things that require any daily backups or weekly backups or monthly backups. It depends how often the equipment gets changed. Some companies might decide to do 3 times a week, Monday, Wednesday, Friday. So if something happens, then what you lose is 1 or 2 days of data. Anything that is lost, it has to be re-entered manually. So you have to see how often you want to do it, right? So this is a backup schedule. I just wrote a little script to back up the wireless controller. I can show you that in class. It's a little script that it will log into the equipment and actually show the equipment how to back up and where to put it, and then put a date on it so you can keep the backups. And then verify your backups. Verified and verified and verified. You don't know how many times we had a backup because, oh yeah, we have a backup. And you try to restore it. There's like, oh, that's not the correct backup, or it's not the file, so you're missing something. Or the backups are not being backed up correctly, and the file is supposed to be, I don't know, 300 megs. It happens to be only like 20 when you see the files. You're like, oops. So sometimes you don't want to overwrite all the backups. What if the the backup is being overwritten every time you back up, so you're not keeping any historical. So you got to make sure that things are backed up correctly. So the author had this 3211 rule that it's okay, but it's a good guide. But yeah, it says keep at least 3 complete copies of the data. And then at least in 2 different types of media. So you want to make sure that it's stored, I don't know, in tapes, on CDs, or a hard drive, or an SSD drive, something like that. At least one should be off-site. Don't keep it in the same place. If something happens to your business, it will destroy your backups. During Andrew, there was a company that close to the Miami airport that the roof collapsed, and we went there. The roof collapsed on top of the server and on top of the cabinet where the tapes were stored, and because of the rain and all that, everything got wet. So the server got damaged, and then the backups were damaged. So make sure you take these things offsite or to a different site. Luckily, Miami-Dade, we have 9 campuses, so some of the departments have set up some disaster recovery for the backup. So Kendall backs up, I don't know exactly, but Kendall backs up at North, and Northwood backs up at Hialeah. Hialeah backs up at Padron campus. Padron backs up at Homestead, and they all have an offsite. Since we have 8 campuses, then it's easy to pick whichever department you want to work with, and then tell them, hey, I want to put a backup equipment on in your site, and I want to be backing up data there. Ensure that at least there's one backup is stored offline. That you just make sure that something it's not connected anywhere, right? It's just on a shelf or somewhere that is not on the equipment, that it's not going to get damaged. So there's 2 measurements here that you have, which is the recovery time objective, which is the time that your network can tolerate an outage. How long can we be down without impacting anything, and the recovery point objective is the amount of data that you'll need to recover and keep on working. It's like how much data do you need? Miami-Dade, if I want to have all the student records, then I have to have at least the records from January or December when the students register. So I need to keep at least 6 months of that data. For my network equipment, as long as I have something that was working last week and I have a backup from last week, I'm fine, because I want to keep the latest copy of the configuration. So I would just want the previous week, the previous month, if anything. That would be the most. But if it's registration and things like that, then I need at least 6 months so I can restore who registered to where and how, and if the grades were posted, you want those grades. So it depends. So the recovery point objective, it depends on the type of data. And that's the end of the module. The previous version of the book had other things that it came into rate the storage and how to size the storage and things like that, but they were taken out. I guess it was taken out of the Netplus certification, something like that. But there's some things you want to explore. RAID, RAID, is a way to store data that is safely, that you can have failures on your drives and still keep your data intact. And I think I mentioned that before on another other modules. But thank you very much. This is the last module of the book, and I appreciate you listening to these recordings.